Welcome to my video lecture on testing the population mean when sigma is given. Here I, as always, have outlined all the possible null and alternative hypotheses for you. I've shown you what test statistics you got to use when you're testing the mean when sigma is given. Here's all the different rejections regions you can have, and here's the two conclusions and two decisions that you're going to have to end up with. So here's a general flowchart of all possible cases you could look at. But now let's specifically look at an exercise for that. So here we have a test of sobriety involves measuring the subject motor skills. So 85 randomly selected sober subjects took the test and the mean score was 41 and a population standard deviation of 3.7. So that means sigma is given. And they want us to test the claim at a 0.01 significance level that the true mean score of all sober subjects is equal to 35. So here the status quo is the average is 35 and you try to population average and you want to test that. So my status quo is that the average is equal to 35. In mathematics courses, we call that the original claim, whatever the claim is, and the counterclaim. So the researcher comes and says, well, let me test that. So I have to test something against it, which is the opposing statement, which would indicate mu is not equal to 35. And we call that the counterclaim. Now, my sample size is 85. I've chosen 85 subjects to verify that. The sample that came out of there was 41, the sample mean, and the population standard deviation is known to be 3.7, and my significance level alpha is 0.01. And here is the given information. Now I have to put this in my regular 4-step, the null, the alternative, the test statistics, the rejection region, and a decision and a conclusion. Okay, so I've written it for you here. So if we look at it, so x bar is 41, sigma is 3.7, n is 85, alpha is 0.01. Now I have my original claim, I have my counterclaim. Now my null hypothesis will always be the equality statement, so mu equals 35, so here that's the status quo. And the opposing statement is that it's not equal to 35, and that's labeled as the counterclaim. Now my second step is to calculate, again, that numerical value, the test statistics, since I'm testing the mean and sigma is given, and you have all these formulas on your formula sheet, that's the formula I'm going to use. So it's a question of just plugging in the values. So I have x bar, which is 41, minus mu, which is 35, divide by sigma, which is 3.7, divide by square root of n, which is 85. And if I type that up, I get some value, and I'll show you that on the next slide. My test statistics is whatever it is. That brings me to my third step, and I'll show you what that is again on the next slide. Now here, I have to first decide if I have a one-tailed test or a two-tailed test. And as I told you, that has to do with the inequality sign in alternative hypotheses. And since my inequality sign is a not equal to, that means I'm dealing with a two-tailed test. If my alternative hypothesis was less than or greater than, then I would be dealing with one-tailed test. Since I'm dealing with a two-tailed test and alpha is 0.01, that means the area in both of these tails is 0.01. And since it's a symmetric scenario, that means half of 0.01 will go in each tail. So the amount of area in each tail is half of 0.01, so 0.005 is in each tail. And remember, you need to find these two values, and it's a z distribution because we're testing the mean and sigma is known. If I was testing the mean and sigma was not known, just like the previous chapter, we'll be dealing with the t distribution. Now, how do you calculate the z value? You have to use the norm dot S inverse of the area to the left. So you need this area here all the way to negative infinity. Well, if this top area is 0.005 and I know the whole thing is 1, then the area to the left will be 1 minus 0.005, which is 0.995. And that's what you would use in your z command, norm dot S dot inverse of 0.995, and that will give you the z value. So let's move on and actually see these values computed since I've done them for you here. So here's my null and alternative hypotheses. Here's the test statistics formula where I've plugged in the values, and the answer is 14.95 if you type that on Excel. Your rejection region here, these two values that you wanted to calculate the z-score for, if you typed norm.s.inverse of 0.995, you'll get this value here. So that's how you get 2.575 as your critical values, and the two red areas are your rejection regions. So at this point, it's quite straightforward. If you take this value here, and that's 0, and don't forget that's the z-axis, and this is the p-axis. So all you have to determine is that where is that 14.95 on this number line here? Well, if this is 0 and this is 2, where is 14? Obviously here somewhere, so it totally falls in the rejection, deep in the rejection region. So therefore, we reject the null hypothesis. So you're rejecting the status quo. So you're rejecting the null hypothesis, you're rejecting the original claim, so there is not sufficient, there is sufficient evidence, to reject the original claim. Thank you.